Okay, 1.6. Other types of equations. Well, this is going to be interesting. What does other types of equations mean? Let's look. Okay. So far in this text, we have learned methods for solving linear equations and quadratic equations. So we're talking about equations, linear being first degree, all right? So equations in the form of x to the first power, or just simply x, and quadratic, so that would be x squared. Okay. Linear equations and quadratic equations in one variable are both examples of polynomial equations of first and second degree, respectively. In this section, we first start by looking at certain high-order polynomials that can be solved using special factoring techniques. One useful technique is to factor out a common factor and use zero product property. Okay, the zero product property is something that we've covered and something that we'll use continuously. Right, what we do is we move all the factors to one side and then set them equal to 0. And so we're going to see an example of that. Okay, so factoring out, excuse me, factor all solutions of the equations 3x cubed. Okay, so what we've done before was, first order and second order polynomials, and polynomials to the first degree or second degree. This is a polynomial to the third degree. Okay, but let's continue, and we're going to solve this the same way we would solve any other problem, right? We're going to move everything to one side, so we're going to add 5x squared to both sides. So we're going to have 3x cubed. And I'm going to put it in descending order, so there would be plus 5, the positive 5x squared would come here, and then minus 2x. That's equal to 0. Okay, so first thing we do, we're going to look at what we can factor out of the entire problem. And what can we factor out of the entire problem? It looks like an x. Okay, and what remains would be a 3x squared, plus 5x minus 2, that's equal to 0, right? And then we can factor this, so this factors into, we're going to factor what's in the parentheses, but remember, bring that x down, okay? This x that I'm writing does get lost a lot, right? And we'll see why here in a minute. And this factors into a 3x minus 1 and a x plus 2. It's equal to 0. Okay, so we factored this polynomial completely. There's nothing else we can factor. Now what we're going to do is we're going to set each of these terms equal to 0. And again, these are pretty easy. We can just do them in our head, right? So first thing we're going to do is set x equal to 0. And this is the one that, like I said, many people forget. Oh no, we might have a no responding here. Okay, good. Okay, people just go straight to these two and solve for that, but forget that x out front. So whenever you do factor something out, make sure you account for it. But anyways, underneath here we have an x equals to a third. Again, we're just setting it equal to 0. This would be x is equal to a negative 2. And this would be x is equal to 0. And that's it. Okay, so the solution set would be, going numerically, would be what? Negative 2, 0, and positive 1/3. And that's how we solve this particular problem. This particular type of problem. Alright, so caution, do not divide both. Yes, yes. So this is good, and we'll see, and I'm going to explain why. Okay. So this reads, caution, and this equals sides by x, right? Because, I mean, we have an x on everything, you divide both sides by x. This would produce that equation, which only has 1/3 and negative 2 as a solution. We know that 0 is the equation, right? if we divide everything by x, we would lose the x solution, and in turn, what we're doing essentially is dividing x, dividing by x, which would be dividing by 0, because x is 0. That's in the solution. Okay, so make sure that whenever you don't do this, it would be tempting to factor x or divide both sides by x here to get rid of it, right? As if it was a fraction, I guess. I don't know. But obviously, we're just going to factor it out. I don't know. I think that might be a little more confusing than it should be. That caution there. Okay, we're going to snip. All right, I messed that snip up. But just so I don't make this program mad, I'm going to pretend like I liked it. Please mute your mic. Okay, so sometimes polynomials can be solved by grouping terms and factoring. You may want to review how to factor by grouping, which was discussed in section review 6, R6. Okay. Obviously, you can go back and look at that, but we're going to do another problem that does involve factor by grouping. Okay, so here's how we do factor by grouping. So here is my rule for you. It's my own personal rule. You're going to see a lot of problems like this, and you're not going to recognize it right off the bat. But for this class, for pre-calculus, for calculus, if you see 4 terms, the first thing you should probably think to do, I mean, besides, can I factor something out of all 4 terms? So maybe it should be the second thing you think to do, would be to split it down the middle and factor by grouping. Okay, so if I split it down the middle, I'm going to factor the left side of that dotted line, and then I'm going to factor the right side of the dotted line. So factoring the left side of the dotted line, it looks like I can pull out an x squared, and what remains would be, looks like a 2x. And if I pull an x squared out of an x squared, well, that just leaves me with 1. Okay, and the right side, what can I factor out? Okay, so I'm going to factor out a positive 4. So whenever you factor out a positive or a negative from the right side of this dotted line, make sure you denote, okay, factoring out a positive 4. Okay, and you'll see why here in a second, or hopefully, if you don't see why, you will in a second. So we factor out a positive 4, and what remains is a 2x minus 1, and that is also equal to 0. Okay, so all I did was factor out factor the left side of the dotted line and the right side of the dotted line. And in doing so, I've now set up a problem that would, let's assume, this whole thing right here was a y. Okay, so now it's like an x squared times y plus 4y. Does that make sense? So that means I would be able to factor a y out, and then what remained would be x squared plus 4. Okay, so we're essentially going to be doing that. We're essentially going to be, factoring that y out, but instead, it's not a singular variable or term. It is an actual polynomial. So I'm going to factor out a 2x. This board's having a rough time today. (2x minus 1). Hopefully it was just because of the autosave feature there. I saw it pop up. And then x squared plus 4, and that is equal to 0. Okay. And then solving for these, this becomes x is equal to 1/2. And this would be x squared plus 4 equals 0. We subtract 4 from both sides, and then we take the square root of both sides. So we would have x is equal to plus or minus 2i. Okay, and then the solution set we'd write Maybe I got a program running or something in the background. This is pretty bad. And 1/2. That's a split set, for example, 2. What is this mess? Oh, these are substitutions. Okay, so this is actually pretty good. So let's
where a is not equal to 0 are relatively straightforward because we know several methods for solving quadratics. Okay, so our methods that we know, obviously be factoring, square root method, complete the square, and quadratic formula. Sometimes equations that are not quadratic can be made into a quadratic equation by using substitution. So when this says sometimes equations that are not quadratic. Again, quadratic equations in nature, or by nature, are ax squared ax squared plus bx plus c is equal to 0. Okay, so when we see equations that are not in that form, a second degree polynomial, we can make it a quadratic by using a proper substitution. Equations of this type are said to be quadratic in form or disguised as quadratics. These equations typically have the form, and there it is, it would be a u squared, right, because we're going to be using a substitution. So if you got lost here and you prefer examples, here are some examples. So for instance, if we've got a 2x to the 4th power minus 11x squared plus 12, it's not a second degree polynomial, okay? But what we can do is make a substitution. That substitution would be some letter b equal to x squared. And by making that substitution, we can now rewrite the equation as 2u squared minus 11u plus 12. Okay, because we said we may let u equal to u squared, and then if we square both sides, we get u squared to go to x to the 4th. All right, same thing, and is this? I feel like that's the next problem. But anyways, I say the same because the second term, right, can be written in the form 2 times 1 over x minus 2. Oops, x minus 2. And we see that now this is indeed the same as this. Okay, so that there are some little minor nuances that you do need to pay attention to for, but that's just one of them. But we do see that the first term is indeed the square of the second, and same can be said for the rest of these examples. Okay, so once we get to the u sub, what do we do? Well, let's go ahead and solve it. I believe would be next. X squared, I don't know, blue and green. Okay, go to blue. So we're going to let x squared be equal to, and we're going to use u as well. Okay, so that means we can now rewrite this equation as 2u squared minus 11u plus 12 is equal to 0. And we're in business from there. Okay, now this is just a quadratic equation that we're used to. We can solve it by
factoring, we need to solve a factoring, quadratic formula, whatever we want to, okay? So, but this is pretty easy, so we're going to go ahead and factor it. So we're going to have 2u minus 3, and then we're going to have u minus 4. Equal to 0. So that means we've got u is equal to 3 halves and 4. Okay, are we done? No, well, of course not, right? Because, I mean, why would I ask, first of all? But we're not done. Why are we not done? Well, because if we look at the original problem, okay, the original problem doesn't have u's, does it? No. So what we're going to have to do is we're going to have to make that we're going to have to make the substitution of letting u, so we're going to let the substitution be let u equal to x squared. Okay, so we're going to have to make that substitution back. So these terms here, we're going to put this up here. All right, this program is not one to work today. So now it's going to turn into x squared is equal to 3 halves, and x squared is equal to 4. All right, and then we end up with x is equal to plus or minus the square root of 3 halves, and x is equal to plus or minus 2. Okay, and now we're done. Okay, so that's what you do. B, C, and D. We're not going to do the arithmetic of that because, I mean, once we get to basically past this point right here, it just becomes a quadratic equation. The only thing we have to do after that is resubstitute